When you roll crit damage on an artifact, there are 4 different values it can get. These values range from the full 100% of a substat's max value all the way down to 70%. This means that even if you successfully rolled into crit damage 5 times, several low rolls could leave you short of 40 crit damage. So in this video, we will explore all the possible values of crit damage along with their respective probabilities. We will start off with a few rolls and work our way up to 40 crit damage and above. Let's get started. When substats are initially generated for artifacts, all 4 values have an equal chance to be selected. With an additional roll, this process is repeated, resulting in 16 different possibilities. The maximum value would be 200% of 7.8, while the minimum value would be 140% of 7.8. Note that the actual value is 7.77, which is rounded to 1 decimal place in-game. For both these values, there is only one way to achieve it, meaning that the probability would be 1 in 16 or 6.25%. Taking a step back, at 190% of 7.8, we have 14.8. There are only 2 ways to achieve this value. The first would be a max roll followed by the second highest roll, while the second would simply be the reverse case. This gives us a probability of 12.5%. The next value would be 14 crit damage, which can be achieved in 3 different ways. This probability turns out to be 18.8%. Finally, the most common outcome would be 13.2, with 4 different ways this can occur, or 25%. Continuing from this point, the rest of the values would simply be a reflection of the probabilities found earlier, giving us a symmetrical distribution. This distribution is quite similar to rolling dice and summing their outcome, where the value in the middle has the highest likelihood to be obtained compared to the edge cases. The main difference is that instead of the numbers 1 to 6, the 4 different substat values were used. We determined this distribution by listing out all the different arrangements that would achieve each value. In other words, permutations. If we take a quick look at crit rate, everything would be similar except for the fact that crit rate values are half as much as crit damage. With our framework established, let's take a look at what happens when there are more rolls to consider. Adding another roll of crit damage will give us 64 different possibilities to examine. The max crit damage for this case would be 23.3, while the minimum would be 16.3. These both only have 1 permutation, resulting in 1.56% for each value. We can continue to calculate the probability for each value by listing out all the possible arrangements. The most common value would be 20.2 with 12 different permutations. This translates to 18.8%, which is also the case for 19.4 crit damage. In fact, a whopping 68.75% of all possibilities will fall under these 4 values. As you may notice, the number of permutations to list out keeps growing, so you may be wondering if there is an easier way to verify the number of permutations. After all, for the next case, the most common outcome would have 44 permutations. Some of you may be thinking that the digits look similar to those found in Pascal's triangle, which is close to the answer, but we'll need to make some modifications. Pascal's triangle is created by taking the 2 digits above and summing them. But for this triangle, we will take up to 4 digits above and sum them together. This would create the digits for the Quadrinomial Triangle. We can test out the newest row for the next case. There are 4 permutations for 30.3, 10 permutations for 29.5, 20 permutations for 28.8, and so on. The resulting probability mass function would be the following, with 26.4 being the most common outcome. One thing to note is that in the worst case, these values will overlap with the previous case. We will address the combined probability later, but for now, summing the 2 probabilities won't work just yet. We can find the probabilities for the remaining 2 cases by creating more rows for the quadrinomial triangle. These will give us the following probability mass functions. Feel free to pause if you would like to take a closer look. Otherwise, let's put into scale these probabilities in practice. The probabilities we previously found assume that you managed to get those rolls into crit damage. To factor in the number of rolls to expect, we can use the binomial distribution formula. For the purposes of time, there will be links to further videos in the description that talk about this topic in more detail. Anyways, for a 3-liner, these would be the probabilities on the number of expected rolls. If we take the 42.2% chance of rolling crit damage once and multiply that by the probability of getting 13.2, we get 10.5%. This means that if we have crit damage as a substat, the probability of it having 13.2 after rolling would be 10.5%. For a value like 23.3, we would need to do this calculation 2 times. The first would be for the case with 2 additional rolls, while the second would be for 3 additional rolls. Summing these will give us 0.51%. Another way to look at this is that 64% of all 23.3 values will result from max rolling twice, while the rest would be the result of low rolls. We can repeat this process to get the following probability mass function. As we can see, most values will fall under 0 or 1 additional roll. Meanwhile, values greater than 30 can barely be seen. So, another way we can look at these probabilities is cumulatively. We can picture this sort of as a progress bar, where 0 represents 0 crit damage, while 1 represents the theoretical maximum, which will be 38.9 for a 3-liner. What we can do is continually add up all the calculated probabilities until we reach 1. This will result in the following cumulative mass function. There are several things that we can take away from this chart. For example, getting a crit damage value greater than 13.2 would already be better than average. By 20.2, we are already 88.3% of the way there probability-wise. In other words, the probability of getting an upgrade would be the remaining 11.7%. As we continue into higher values of crit damage, the chances of rolling better decreases significantly. In fact, rolling 4 times into crit damage is already incredible even if they are low rolls. But this is just for a 3-liner. We can go even further with a 4-liner. Using the binomial distribution formula again, we can obtain these expected probabilities for a 4-liner. We can then multiply this by the probability of obtaining each value. For example, the theoretical maximum of crit damage would be 46.6. There is only one way to get this value, which is to obtain the max value of crit damage 6 times. Multiplying this by the probability of getting 5 additional rolls will give us the following. With odds in the millions, you would need lottery levels of luck in order to achieve this. Fortunately, getting more than 40 crit damage would be easier, as there are more ways we can get the other values. Including the probability of rolling 5 times into crit will give us this probability mass function. We can sum all the values above 40 to get a probability of 0.042%. Still difficult, but at least more possible to achieve over time. Note that this probability assumes that an artifact has crit damage as a substat, so in reality, things are a lot more difficult. Taking a step back, this will be the probability mass function for a 4-liner. The values we just looked at are barely visible at this scale. What is visible are most values below 30 crit damage, illustrating the difficulty of getting anything above that. We can also observe this when looking at the cumulative mass function, with values like 23.3 being already at 90%. So, if there is anything you should take away from this video, low rolls don't matter that much. At low values, the chances of getting an equivalent artifact with higher rolls is almost a certainty. While at higher rolls, the fact that you managed to roll that much crit is already an accomplishment. What matters most is the number of rolls you can get into your relevant stats, although it never hurts to get a 40 crit damage piece every now and then.